Okay, good. Let us start. Uh, Today, what we are going to discuss is the system view of AI. And this is not actually going to be a full-fledged lecture. This is going to be a description of what tools you need to know for doing your project, because you are section 2 and you are supposed to do a project, and what are the skills needed, what are the tools needed, and what you can expect to use or to employ during your project. Uh, that is the objective of this session. What is the infrastructure that we are going to use for doing this project? And so AI is not actually a model weights. We are not interested with, not only interested with the models, we are also um, interested with what problem we are going to solve, and that is the objective. And if you look at the entire view, what are the components that are involved with AI? It is the society, the system, the model, and the data, of course. So the data, the hidden patterns that lie within the data that are captured in the model, and you deploy the model, and the model uses various parts of the societal resources, and that's what we call infrastructure. And then the model gets deployed, right? But what is important here, intelligence is operationalized through systems, and this lecture focuses on that infrastructure. What are the infrastructure needed? The first infrastructure needed is definitely computing. The second infrastructure needed is network, and third infrastructure needed is which is perhaps the most important, data. So the all these things, there is a nice article that appears on NVIDIA blog. If you are really interested, the article is actually the speech given by NVIDIA CEO Jensen Huang, and the article name is AI is like a five-layer cake, and the bottom parts are the infrastructure where he discussed the memories, GPU memories, the various uh, cloud servers that are needed, and semiconductors. But on top, the topmost two layer in this five-layer, uh, I would say the five-layer paradigm, the top two layers are the model and the applications. These are the two things that would interest us, but at the same time, we should be also aware of the bottom layers of the this infrastructure, that is the semiconductor chips, electrical energy, and various other resources. Anyway, all through these layers, the intelligence is operationalized, and of course, it doesn't come free. There is a cost. So I'm starting with this discussion with something that is very important. Perhaps we are not aware of this when we do machine learning training, but when we talk about the system, this is important for the industry. And part of the objective of this internship is to make you, equipped with some industry grade skill sets. And that's why this, I would say, the industry view is also important. You have got the data set, you have trained the model, but while deploying the model, how much energy you're expending, how much cost it is incurring, is everything efficient? All these things are important when you are deploying the model. So this cost perspective comes with this entire project lifecycle that I often show during my discussion, and we would keep coming to this part. But the important point here is, I mean, this part. I mean, let us take a quick look. These are the components that are involved in the project lifecycle: problem statement, data collection, EDA. This is the EDA part, then model training, then deployment, maintenance, and all these things. I mean, they keep happening, and we keep going back to various parts. And it's not one shot, or it's not a single way forward. That's what I try to mean. You need to go back to various stages, and you need to start once again. So it's iterative in nature, and this process is called ML Ops. We'll be coming to that in whole details. But right now, what I'm going to make you aware of is this part, the technical debt of ML systems. And it's actually a nice paper that appears in NIPS 2015. And actually, the funny thing is the ML code that we are so much concerned with, that occupies this tiny part. What is the other parts of the ML system? This is the data collection, data verification, server infrastructure, then feature extraction, process management tools. So this is the system view of the entire thing. I mean, you have written the ML code, you train the ML model, but ultimately you are going to solve a business problem. When you are going to solve a business problem, which happens when you work in the industry, when you solve a business problem, all the other things come into the picture, and you start thinking about the design choices regarding all the other things. Now, the thing is, this is the when we talk about the technical debt of ML system, that is the technical debt means the cost of ML systems. Now, the cost, when we talk about the cost, look at this caption. Only a small fraction of real world ML system is composed of the ML code, as shown by this small black box in the middle. The surrounding infrastructure is vast and complex. ML code is the programming done in Python. Yes, Python, C++, whatever when you write the code. I mean, for example, what is the machine learning library? So there was a question, perhaps the others are not able to understand what I'm referring to. I'm referring to a question that came into the chat box. What does it mean by the ML code? ML code is the code that you write to train a model, right? For example, the machine learning library that we use, what is the Python machine learning library that we use? Scikit-learn. There are other libraries. For example, if you talk about the deep learning library, there could be PyTorch, there could be TensorFlow. So all these libraries are used to write ML code. What I'm trying to say is that the ML code is actually a tiny portion of the entire system. You need a lot more things to actually make something industry ready or deployable in industry. By industry, I mean where something solves a problem. We are in the academia. For example, when you are doing something, sitting in your classroom or as part of the coursework, that is the academic part of your journey. You write something, you don't care if it is, I mean, producing result, or you get excited. You get excited when the accuracy or so-called metric jumps 2 or 3 points up. But do you actually, I mean, does this accuracy really mean, if you want to take it to the industry, if you want to take it take it to solve some business problem? That's what the industry is interested in. Is it solving a business problem? If it is solving a business problem, is accuracy important there? May not be. Perhaps there is something more important involved there. So this is the topic of discussion today. I would come to those parts, why accuracy may not be the right metric, why other things are important. So what I mean to say in summary is this ML code is actually a tiny part. There are whole other things involved. What are the other things involved? For example, suppose suppose one company in Bangalore, I'm just cooking up things. I'm not actually referring to any particular company. It may be fictitious, but just to give you some idea, I'm telling this story. One company in Bangalore, they may be. I'm saying this because part of this is related to me, and I will tell you when it is coming into the discussion. But otherwise, it is a fictitious story. Suppose one company in Bangalore, they are working on building a digital stethoscope. This digital stethoscope is digital stethoscope. That means the heart sound that your heartbeat makes that can be recorded and digitized in the digital form. And that company gets in touch with you saying that we want to predict if that heart sound contains any abnormality. And you are the data scientist, all of you are data scientists, a data engineer, whatever you call it. The company then asks you, can you create a machine learning algorithm that can solve our task? And you immediately say, yes, we can. Give us some data, we train our model. We have a very sophisticated deep learning or any transformer architecture we would employ, and then we would be solving your problem. Mm. And the company gave you data and you tell them, well, we are getting 99.9999% accuracy. The model is performing perfectly. I mean, we are very happy to deploy this on your server. I mean, please deploy this model on your server. The company gets excited. The company then uh, the company engineers then work with you and they deploy the model on their server. And there comes the realization that your model is working perfectly, maybe I would say with almost 100% accuracy, almost 99.999, whatever, how many nines you can put. But actually, that is working in development environment. It is failing when you are deploying. Why? And also, the deployment is not efficient. Why? Because look at this diagram. When you are serving the model means when you have trained the model is giving 99.99% accuracy during your development, I mean, for your training data. But when you are serving, I mean, when you have deployed the model on their server, the 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 doctors are finding that the accuracy is not that good. I mean, the doctors need to frequently check the model performance again and again. And that is when the spirit goes down. That's when you sense that things are not perfect and this is not working. And not only that, not only the degradation of the model performance, there are other things involved. You are running heavy duty transformers that are requiring a huge GPU power. And while using the GPU, you are burning their money, you are burning cash. So the model performance is not good. On top of that, you have added huge amount of GPU computation. And not only that, the when the company is feeding a lot of data, when the data is are coming so fast to your server, all the heavy duty machineries are delaying your I would say the response time. It's increasing the response time. So the users, whoever it is, maybe the hospital authorities or others, they are waiting for a long time to get their response. That is not good. So all these things, perhaps now you are starting to realize how difficult it is, right? So these are the hidden costs of machine learning systems. And why it happens? It happens not for a single reason. It happens for a whole lot of reasons. And that's what we are going to perhaps it's a huge topic. We are I'm going to give you some a broad level motivation so that you know that this field exists and what are the challenges in doing industry projects. It's not like academic semester exercise. It is a lot more demanding, and you can understand when you are working or when you are deploying this model, you need to work with a team. It's not that you work in an isolated fashion, develop the model, and you employ some fancy algorithm, uh, very sophisticated algorithm, and then you say that, yeah, but I'm getting good results. That doesn't work. You need to work as part of the team. And this team is definitely software engineering team, quality control team, management team, and of course, the customers who would be using your model, right? So if the customer is not happy with this long response time, then nobody is happy. I mean, your model is not working well. So this is the hidden technical debt of ML system, and my intention is to make you aware of this thing. Uh, I mean, there are a lot of other things, perhaps. Okay, let me try to walk you through them quickly if I'm able. Otherwise, the other things are, I mean, we need to cover many other things. So the core thesis is that the ML code is tiny, the infrastructure is massive. By the way, if you are interested to study them in details, this is the paper you must study to understand how complicated these things are. The complex, I mean, this principle, changing anything changes everything. I mean, because it's a system view. Why it is a system view? This is important. System view means all the components are involved in delivering something. That is a system view. ML code means just a small part of that. System view means a system comprises many components, many parts. By component, I mean parts. So, as an ML engineer, as a data engineer, as a data scientist, you must know what are the parts of an ML system or AI system. So, what are the components that build a whole ML system? That is the main uh, question. So, there are comments in the chat. So, when I said that, so there is a comment in the chat box. Someone said overfitting. Overfitting is just a small part of the problem. I mean, the participant is trying to hint is when I said the model is performing very well in the training, but when you deploy it, the model degrades. So the reason perhaps the intern is trying to imply that the reason is overfitting. So overfitting is definitely a, I mean, a possibility, but there are other things that go into the, I mean, uh, I would say the model development phase. I mean, by overfitting, the if those of you who don't know, overfitting is when you make assumptions that are not valid. That is the thing. What kind of assumptions? When you make your model so powerful that instead of learning the pattern, the true pattern, it starts learning the noise. That is the overfitting. And definitely when it happens, I mean, let me show you a quick example that clears everything. Okay, so when he said about overfitting, he or she said about overfitting, that is the thing. Suppose This is the data, training data, and you want to learn the pattern. Pattern means you want to draw a line that uh, I mean that, for example, this is, you want to draw a line that actually more or less captures the pattern. So it's linearly increasing. It is linearly increasing. That is the broad overview. So if you draw a straight line, something like this, then it more or less shows it. But instead of a straight line, you assume that I would draw a line that would fit every point. So you perhaps imagine some ninth or 10th order polynomial, and that polynomial starts going through every point, right? Every point. So is this the pattern? This is definitely not the pattern. So what you did is that you made a, you assume a model so powerful. So this is the crux of the matter. I mean, if you understand this part, then you would be knowing what overfitting is. So you assume a model, maybe ninth or 10th degree polynomial, that is so powerful that instead of learning the pattern, it starts learning the noise. That is overfitting. So when you do this, instead of learning the pattern, it starts responding to noise by trying to go through each and every point. Then your model is super powerful, and definitely it is not going to give you the overall pattern, right? And when you start giving it test time data, it works miserably. That is the point of overfitting. So definitely this is one thing. Another thing is underfitting. Underfitting is overfitting. If overfitting can be a problem, underfitting can also be a problem. For example, this is, perhaps you are building a radar, AI powered radar, that is trying to predict the trajectory of a ballistic missile. What is a ballistic missile? Ballistic missile is a missile that operates under the gravitational forces. I mean, so the gravity is uh, considered in computing the trajectory of the missile. When you are throwing a missile, you are definitely thinking of some point to hit with this missile. So you have this part in your mind. And what I showed you here is the parabolic path a projectile traverses, right? So you have these data points and you want to fit a line through this. But instead of parabolic means a second degree polynomial, so ax square bx plus some kind of this parabola. But what you did is that you thought that I don't have that much computational power. I'm running my algorithm on a simple, perhaps some Arduino or very cheap device. I don't want to go with a second degree or third degree. So what you did is you try to fit this pattern with a straight line. Definitely, this is not going to work, right? You cannot use a straight line or a linear model. I would call a linear model. Ax plus b, something like this in 2 dimension, to fit this second degree pattern or the parabolic or projectile pattern. So you are underfitting. So both overfitting and underfitting can be a problem. So how to mm, hit the sweet point, right? How to assume model that would be the perfect. For example, maybe in this case, we need a 2 degree polynomial. In this case, a linear line is good enough. So this comes from practice, experience. This comes from exploring the data set, domain knowledge. So there is no uh, short answer or there is no silver bullet that fits all. So this comes from experience. But when you talk about this digital stethoscope problem, there can be other things. So here I'm involved because I have worked on this kind of data set where the PCG signals, the recorded signals, are analyzed to say if um, the heartbeat is containing some abnormality, if the doctor's attention is required. So what I've seen is that when you are training your model in the hospital environment or in the lab environment, the the neighboring noise is absent. But when you are doing it, perhaps as part of a camp or in the outdoor, or maybe in the rural setting, when someone is carrying a portable digital stethoscope to the remote areas, and they are checking the heartbeat of people. Uh, I mean, definitely in the outdoor setting, then the neighboring noise or the surrounding noise, that becomes very challenging. That becomes part of the problem. And the noise, because you are recording the audios, perhaps you are capturing the PCG signal from a kid, from a infant, from an infant. The infant is moving a lot. Perhaps he or she is not very happy with this. Then there is this rubbing sound. All these things make your hospital setup invalid. The assumptions, the model considerations, the kind of training that you do in the hospital setting, that remain no longer valid in the outdoor setting. Those are the things, or those are the factors that you didn't consider in the hospital environment, but those are becoming part of the real life. They are the things that are the reasons behind a model's failure. So since someone mentioned this overfitting or underfitting, I shared this experience. Why a model can fail? A model can fail in 1,000 ways, but these are the things. Assumption is one such thing, that the model assumptions that you are considering in the model development, they are no longer valid in the test time, as I mean in the inference time when the model is deployed. Okay. Anyway, so let us move on to the next part, the data dependencies. So configuration, there are a whole lot of other factors that actually build this entire system. Those are responsible for all these issues. And the cost also comes from the environment. For example, there is a nice thing, why particularly in the LLM era, the as you may be aware that some of the companies are uh, deciding to move away from expensive AI usage, and the reason is that the licensing cost is going through the roof, and there are whole lot of expenditures that people were not aware of. And regarding this, I can share one funny incident that happened, perhaps little dated, but still relevant for our discussion. That some of you perhaps use this the words like "thank you," "please," and they are burning the money. They are using tokens, and they are processed by the OpenAI, ChatGPT, Gemini, Claude, all these AI models. And when you are using this "please," "thank you," you are the person alone. But when there are a million people using all those things, then million tokens are being used, and the cost is going high, cost is going through the roof. And these are the environmental debt, because to keep them running, to keep the GPUs running, you need a lot of cooling effort. And the cooling effort and the electrical energy that you are expending, they are they are causing considerable, uh, I mean, expense in terms of your um your budget. So these are the things you need to be aware of. Why or how we should be using our decisions. I mean, not decisions, using our resources to make optimum decisions. So this thing, the machine learning operations, they can be divided into three broad parts: the design, development, and deployment. And we have, so design is, so the three parts. Remember the chart that the this life cycle diagram that I showed. The first part is the design, the middle part is the development, model training, EDA. This part is the development, and final is the deployment. So you can think of this entire process as design, development, and deployment, and these are the finer actions that are involved here. And this is a little bit involving. When you deploy a model, you actually version your code, you version your data set, you do a lot of stuff that is similar to what software engineers used to do in the name of DevOps. And similar practice is being used in machine learning too, and we call them MLOps. We call them MLOps. And this book is extremely important for understanding all these things, designing machine learning systems. And this book actually, this is the, I would say, the core of today's discussion. And the discussion starts from this book. What are the considerations that are used in building the machine learning system and deploying such system? What are the components and how to design the components. For example, someone said overfitting causes the deployment failure. Someone said underfitting causes the deployment failure. So what are the actions that you need to prevent such failures? And definitely early in the process, because the failures are expensive. So what are the things needed? So all these things are part of this book, and I would discuss some part of this book because in this 2 hours, it's not possible to discuss a whole lot. Uh, it actually, um, it is a part of perhaps 2 quarters or a single quarter coursework at Stanford. So in 2 hours, we won't be doing justice to this beautiful book, but at least you know that you need to go through this book to know all these things in details. So these are the components, and so I mean, I didn't describe the components. The components are, these are the parts of a project life cycle. The AIML project lifecycle, and I would be discussing some parts of it. But I started this discussion by saying that you need some tools, some skills to do your project. This project is part of your industry experience. So definitely there would be a lot of, I would say, vague things, because when customer expresses their requirement, even customer is not sure of what he or she wants. So sometimes the description would be vague, and your job would be to convert the description into a machine learning statement. So when you would be getting the problem statements from your mentors as part of this internship, this is something important. Don't expect that these problem statements are well defined. They are never well defined, because that's not how industry works. It's not like you download something from Kaggle and the data is well labeled, and even there is no missing value, everything is well organized. This is not how industry works. In fact, defining a machine learning problem statement is very difficult from, a business problem statement. So once I asked a few interns to come up with a strategy for detecting changes in a locality. Physical changes. For example, um, uh, has there been any deforestation or any encroachment in the water body areas? Or has there been any rapid expansion of these urban structures? Buildings and malls, shopping malls, all these big buildings, are they coming up rapidly? So how we can do this thing? They were kind of clueless because they were not able to convert this into a very specific machine learning problem statement, where to get the data from, which area do you want us to look into? Do you want any particular object to segment? For example, do you want us to segment a tree or a building? Do you want to classify a pixel into building or tree? So these are the questions that come from a student who has recently started playing with the machine learning computer vision stuff. But what you need to do is that you need to understand the intent of the customer. In this case, I may play the role of that customer in industry. So you need to understand what is possible, what is not possible within this 1.5 month time frame. You need to make bold assumptions that this is what is doable, and I want to focus on this part. You can list out 3 or 4 objectives, and when you are making assumption, you can remove those parts which may take time. And you have when you have a lot of options, you need to reduce your option space. Like, I would look at this particular area, maybe in Madhya Pradesh or in Bangalore or somewhere in Bengal, and I won't go beyond that. I would strictly focus on this area. That is part of my assumption. So these are the things that should come from you, and you make your problem statement. And definitely, that is not the end of it. You discuss with your peers, your group members, you discuss with your mentor that, look, here are the set of assumptions I have made. Are you happy with this? If I go with that, are you happy with this? This is how you interact with your client in the industry. If not, then you revise your problem statement, and your machine learning problem statement gets revised too. So you convert the business problem into a data problem. What are the data you need to solve the business problem? That is the main idea. Anyway, there are questions. I cannot answer your question because I need more. I have seen your question, but the question is a little vague. Can you be a little specific? I don't understand what exactly a project to. Okay. Can you tell what exactly a project is to make in college? How do I know what kind of project you are supposed to do in college? Um, the project is, sorry, the question is a little vague for me, and that's why I was not able to answer. Anyway, okay. So the tools and techniques that you need for doing your stuff, the okay. The first thing that you need is the idea of how internet works. Why? Because you have learned Streamlit. So Streamlit is a web application that exposes your application, the data, the model that you have. Perhaps you have trained a model on your data set, and you are exposing the model to the others to use. For example, perhaps you are predicting something. Now, how the Streamlit works, what are the various endpoints, how API works, these are the things you must know. So, I mean, Streamlit is a web application, but Streamlit is grounded on the idea of how internet works. So the IP, how IP is defined. IP means Internet Protocol. What is the concept of port? How port works, right? So how the client and how the server. I mean, many of the students do not have a good idea of client and server. So all these things have been covered. I'm just asking you to be aware of those parts so that you know the client server model. Client is a computer program, server is also a computer program. But what it is the relation among them? So all these things are important. And here I want to show you something quick, that the idea of API is important from design considerations. For example, someone is asking, can you tell any example of a project they do in real life? I mean, if you ask about, if you're asking about what is an industry grade project, I already gave you an example of this digital stethoscope, and you can think of this. Another project that I mentioned is change detection in geospatial setting, where rapid urbanization or deforestation, all these things are happening. So these are some industrial projects which are little open-ended, little vague, because I didn't actually tell you about the data part. What would be the data? What kind of models need to be built? That is open. And you need to make decision. You need to make decision so that you can convert the business problem into a data problem. So this is where you need to show initiative. You need to make choices. You need to talk to your peers, your mentors, and make it a part of a teamwork. You decide your choices of the data. That's how it works. So if you mean that what kind of industry projects I'm talking about, these two examples can answer your question. And if you mean to say something else, then you need to be specific in your question. Okay, so where I was, yes, I was going to share a PowerPoint. And this PowerPoint is the idea of API. This is important because in the earlier days when we were building a system means the digital application. Perhaps you are building an e-commerce application. So all the authentication, shopping cart, payment gateway, invoice, order, so they used to reside in one single server. A server means just a computer, right? Nothing else. Now, if you are, suppose you have one server, but your number of customers is increasing and you need to increase the number of servers. You buy another machine, you buy another, and this way you go on buying other servers and you replicate the whole code, this entire code base, authentication, shopping cart, payment gateway, everything. You go on replicating this way. This was people understood that this was not very efficient, and this kind of design is called monolith design. This was not very efficient. So with time, we started entering into something called microservices. What is microservices? Microservices means the authentication, shopping cart, each application would be run by their own uh, by their own computing. I'm hesitating to use the word process because those of you who do not come from computer science background, but maybe you would be knowing what is a process is. So this authentication, shopping cart, payment gateway, they would be standalone services. That's what I mean, standalone services. They won't be running as process inside this single computer or single server. That is not the thing. The thing is that this payment gateway or maybe this invoice generation service can be a, a service that maybe we are buying from a third party that is not running inside our server. This is not running inside our server, running somewhere else, and we are buying, and they're giving us this service in the form of API. They are giving this service in the form of API. We are consuming their API, and that's how we are using the API that they are providing us. And through this API, we are requesting the invoice, and in response to our invoice, they are sending us the generated invoice. Same applies to order processing, same applies to email. For example, when something happens that triggers an email, and email sending is used by another service. Maybe we are buying that email sending service from Google, right? So Google is providing us another API, and using that API, we are sending the service. So all these APIs, if you remember your Streamlit, all these APIs are very important to build your endpoints. And some of these APIs would be where you deploy your models. You consume data and your model would be giving you the prediction, right? That is the idea, main idea. So microservice is implying this every service is actually a microservice. They can exist in standalone format. They can exist out of this server. Perhaps those are coming from another server, and the way we talk with those server is in terms of the API. We use API to talk with the servers. That is the main point. So in summary, what I said is that all these processes used to happen in a single server in the past, that is called monolith. But nowadays, all these things happen as a standalone service, and this standalone service can be purchased from outside, can exist inside the same machine, but whatever it is, they exist as microservices. We call them microservices, and we talk to these microservices in the form of API. And there are a lot of other things. For example, this people are saying APIs are eating the world. When you are calling your cab, when you are maybe placing your order on Zomato or Swiggy, all the APIs are getting called, all the APIs are working, the bill generation, invoice generations, all these are happening in the form of API. And these are happening from your mobile device, these are happening on the Zomato Swiggy server everywhere. So let us take a look for those who are not that much exposed to the API part. So how APIs are important for data scientists like us. So let us take a quick look at how the APIs are used for the data scientists. I mean, by the data scientists. I mean, here I can show you something. Share. So this is the air quality index from data.gov.in. Data.gov.in is a nice portal where they expose various data pertaining to India. For example, the air quality index. And they give us various data information. For example, the sulfur dioxide, nitrogen dioxide content in particulate matter content in air. And they serve this information as, again, as microservice. You can imagine them as microservice coming from other servers, and we can talk to these microservices through API. They have exposed their API. So if you click on this thing, I mean catalog API, for some reason it's not, it's asking to, it is asking to login. I don't know. So I'm using this example from past lecture. Maybe they have upgraded. Anyway, so the idea is if you click on the catalog API, you can, maybe the website is down. So there, if you click on these APIs, there are a whole lot of APIs used for different data sets. So what I want to show you is that if you click on that particular API link, catalog API, then you would be able to see the API endpoint. And by API endpoint, what you can see is this. So that was the API endpoint that I used in the past. So this is the API endpoint. Some of the API endpoints would require keys. Keys means the authentication. And you can get your authentication by logging in. I didn't log in. But if I logged in, I could show you my keys, which is not supposed to be shared in public, your personal key. So the key is required. But initially, I mean, if you are just interested in knowing how it works, this is how it works. Requests library, Python requests library is absolutely important for this kind of thing. And you use Python requests library with this kind of structure. Again, the structure is important. Memorizing code is not that important at this point in the age of AI tools, but the structure, knowing how it works, the structure, overall structure, for example, the URL, and then you need to define the header, and you need to call the request get method, making request to this URL with the headers. Sometimes you need to pass extra information to the header, perhaps when authentication is needed. And when it, so I said API, so microservices. So I'm talking to this government API, and it is giving me the response. And when I'm displaying the response.text, I get to see this kind of stuff. For example, this is the structure, Ministry of Environment, Forest and Climate Change, and these are all the data points. For example, this is the time, lat long, all these things. What are the air pollutants? So in this area, these four data points are perhaps available. So the output is truncated. I'm not sure if I would get the whole output here. Let me try if this. Oh yeah, I get to see the whole output. Yes. So it is a list of locations that I get. This is something the API provides me. Without credentials, you get to see maybe 10 or 12, not more than that. But if you log in, if you use your credentials, you can uh, request uh, with a lot of personalization. For example, any particular area, any lat long, any time, all these things. You need to see the documentation. What are the parameters the API takes? So API is nothing but a function. In from Python perspective, it is just a function. See, look at the API. Request.get, it is just a function. So request.get is actually asking the API endpoint, of the government website for the required information. And the API endpoint is giving the data back, which we are capturing in the response variable. That is the idea. And if you go through all this data point, you can see India, Andhra Pradesh, Vijayawada, and this is Tirupati, all these locations with lat long, they have pollutant, ozone, pollutant, PM10, all these pollutants are recorded. Some places perhaps giving the ozone parameter, some places giving perhaps the other, the PM10 parameter. And this is how you can definitely recognize this dictionary structure because the API payload happens in the form of JSON, right? The JSON structure. So knowing how API works, knowing how the JSON works is absolutely mandatory for you. You need to know how they work. So someone asked any free, open, safe, secure, non-gated API for official real-time air pollution data that do not need any key. So I would also be interested to knowing answer to this if anybody has any information to share. Otherwise, I know that there are a lot. Perhaps I cannot tell you right now on top of my mind, but there are a lot in India, in other Western countries too. But data.gov.in is definitely a source. There are other authorities, maybe. If you do a Google search, I've seen a lot of open source projects too, I mean, on GitHub. Uh, No, they're in India too. I mean, and also, I mean, it's not that you need to pay for getting the key. You need to register. If you register, you would get the key, and using that key, you can get more data than that I'm showing here. So it's not that you need to pay always. Okay. So, but this question is a nice question. So this shows that you have started exploring what is going to be my next topic. What are the data sources, right? So data sources is important. One important data source is this data.gov.in. I've been using it for a long time. They have many different kinds of data set. Okay. So, so talking with API using Streamlit, using the API endpoints in the backend, that is important skill that you need for your project. Another important skill is Git and GitHub. So this is going to be a revision of what are the things you need. Version control and collaboration, and the version control, you need to really brush up version control because you would be working in a group. And so I don't know, even after saying all these things, when the interns start project, they feel lost. I mean, they need to start studying GitHub once again. But it's okay. I mean, if you're new, that's okay. But otherwise, I mean, you can expect that Git and GitHub to play an important role in your project. So you need to know the version control, main idea, the idea of working directory, the staging area, the local repo. When you are working in the working directory, you are pushing your changes to staging area, which you are committing into the local repo, and how you would be pushing those changes to remote repo, and how you would be managing the branches. So all these things are important for your project. So repository management is an important skill set. Okay. So I'm not going deep into it. Those things are covered. So in summary, what are the things that I've said? That talking with API and quick web application development for visualization, and GitHub for version control, and working with your peers, those things are important, right? And perhaps database is another thing. I know that you have been taught database in details, MySQL database, and also maybe SQLite. That is my favorite data set. Sorry, database. But I know perhaps you have been taught a different database. That's fine because SQLite DuckDB, or maybe PostgreSQL. They are all MySQL databases. So the underlying pattern is same. But the other thing, for example, the non-relational databases like MongoDB, like Redis, all these things follow nice dictionary structure, key value pair. So it's not difficult to learn them. The way you have managed JSON format, it is something similar in that case. But you need to learn, you need to brush up your knowledge if you are not that familiar with the database. Both the relational database and non-relational database is important. And at the same time, file format is also important, because when you are, for example, someone asked what are the data sources. Now, when you talk about the data sources, it's also important to know how the data sources distribute the data, in what file formats they distribute the data. For example, is it going to be in CSV format? Is it going to be in JSON format? Or it is going to be in any other binary format, and you need a parser for that. So file format is also going to be important. Okay. The next thing is that you need for system view, database, API, the version control, GitHub for collaboration. The next thing that you need to understand, I mean, you need to be comfortable with, that is how this kind of system is made with containers, the idea of containers or Docker. So let me motivate it with a case study. So this happened with me. So one day, this is actually a real life story. I'm not disclosing the name of the client. It is not ethical, but let me share the story so that you get to have your learning lesson. A client came to my office, and the client is actually using a sophisticated high-end camera for industrial use, and the client requires software support. Now, the company, I mean, my client's company has acquired plenty of image dataset in particular format, but the camera manufacturer, they initially they use the Windows system to provide the sources, but later they move to Linux system, Ubuntu or whatever. I mean, the other Debian system. They started giving the SDKs in the Linux in the Linux format. Now, the client earlier, the client spent a lot of money in setting up their infrastructure with the Windows setup, and now with the sudden move of the camera manufacturer into Linux system, the client is now kind of clueless, because they have already invested a lot of money, but now uh, it seems that they need to invest a lot more to take care of this transition. It is not efficient, it is very inefficient, and it is not reasonable, and they are not getting much support from the camera manufacturer. Also, what is more serious, the camera manufacturer has changed their driver, I mean the file format. They have changed their file format, they have updated their file format, and the file format only supports the Linux SDKs, not the Windows SDKs. Now, the GitHub code base of the camera manufacturer is so buggy that when I was trying, it is breaking a lot. I installed on my machine. Initially, I thought that it's a European company, so I was expecting good result from them. It's a reputed company, but it is so buggy that I end up uh, uninstalling the SDK that I did, but when I uninstalled, some of the system files got deleted too. So I was my system was in a mess. What to do in this kind of situation, right? This kind of situation requires something called Docker containers. In the earlier days, when we were in schools and colleges, whenever we used to have this Linux along with our Windows system, we used to dual boot them. But those days are gone, because if you do dual boot, you would be having only two operating systems. But nowadays, you may want several operating systems in one shot, right? Maybe 3 or 4 Linux operating systems. One is the Red Hat, one is Debian, or maybe two different kinds of projects are going on. And you may need Windows 2 for your office needs, or maybe there is a project that requires Windows. So definitely this kind of designs where you dual boot your system is not scalable. Nowadays, those of you, sometimes people ask that I'm working in Windows, how can I use Linux? So the best choice is to use WSL. The full name is Windows Subsystem Linux, WSL. And WSL installation is very easy. You go to PowerShell, and then the command is probably WSL space dash dash install or invoke, something like this. If you search on internet, you'd be able to see. It's very easy. WSL space dash dash install, I guess. Install or invoke. Oh, install. Yes, WSL install. WSL dash dash install. And with that, you'd be able to install, or you'd be able to have Ubuntu on your system. You don't need this dual boot kind of stuff anymore. But none of these options are scalable. This dual boot system or the virtual box, somebody used to have virtual box, these are not scalable. So we have a new technology that really helped us in this area, that is called Docker. The Docker is something that actually uses your own operating system. Uses, for example, it is easy for me to describe Docker from Linux perspective, because that is what it was designed for originally. So this is the infrastructure, means the hardware, your laptop, your desktop, whatever. And on your hardware, there is something called host OS. Host OS is your own OS, perhaps the Ubuntu system. And this Docker engine actually allows you to run multiple operating system. Perhaps this operating system is Ubuntu 14. This operating system is perhaps Red Hat. This operating system is perhaps Ubuntu 24. So why do you need Ubuntu 14? Maybe some legacy application requires Ubuntu 14 and you need to check it out. That's why you need, nobody knows what how the industry goes. Perhaps your one customer comes and she is saying that we have a legacy system that use Ubuntu 14. Can you help us with this? We cannot throw it away. A lot of important data is there. So that's why you may need Ubuntu 14, who knows, and you just spin off a Ubuntu 14 OS, and all these things can run on your system, and they can run on your system because the kernel that actually consumes the most of the space, that is not shared. Yeah, sorry, that is not isolated. I mean, that is not used in every container. That is actually shared in the form of this I would say the Docker engine is facilitating this. The host OS is acting as the main OS and guiding all these containers. And these containers means the OS that is running in your system. See, you do not see any kernel file here, because the kernel is part of this under this the layer underneath. Docker engine and host OS. They are actually sharing the kernel. The kernel is not part of this operating systems that are running. What is here is bin libs, just the binary and the library files. And on top of that, you can run your own application. That becomes your running container. So you can run as many containers as you want. On my decent laptop, I have run maybe 10 or 14 containers at the same time. So 10 or 14, 10 or 14 or 14 or 15. I think I have gone even beyond that, maybe 15 or 16 containers running at the same time. So these containers are isolated operating systems that are running. And this is the beauty of Docker, isolated operating system. And this isolated operating system is running application one. Perhaps this system is running application one. This system is running application two. What are the applications I would show? I would show you. This application may be Streamlit application. This application may be MySQL application. This application may be some HTTP server. And they can run this way. And you don't need to install like in the past days you install something and you cannot install Ubuntu 14 and Ubuntu 24 at the same time on your machine. But with Docker you can. That is the beauty. I repeat, you cannot install two operating system at the same time on your machine. But since you have Docker, which are running as isolated machines, you can. So what is the difference with the virtual box or virtual machine like this one I showed in the earlier days? With the virtual machine, the entire operating system, including the kernel, used to be part of the virtual machine. That used to make them bulky, maybe 25 GB, 30 GB per virtual machine. But these containers are sometimes they run with few hundred MBs. They run with few hundred MBs. These are so tiny in size. And there is another thing. The thing is that those of you who are coming from computer science background, these containers run as process. These containers run as process, standalone process. So, I mean, some of you, when the computer becomes slow, some of you run the process manager, right? And to delete the processes which are unwanted or which are consuming too much of CPU resources. So that is the idea of process. And these containers, these Docker containers run as process. And this is one very useful technology that you need during your project. And since they are not like the virtual machine, they are not using the OS, they are not using the OS inside the container. These containers are very I would say light in size, lightweight, I would say. Lightweight, that is the right term, lightweight. These are the heavy duty virtual machines. For example, as I said, 25, 30 GB space they need, but here all you need is few hundred MBs. Of course, if they keep accruing data set, or if the model is being trained here and the model is growing in size, then of course the container size increases. But that's up to you how you manage the containers. If you are happy with the container size increase, it's okay. Otherwise, you don't need. But how all these things appear? This is in theory, right? I mean, how do they work? How do I run Docker? So if you are using Linux, it's easy. Just you use this command and Docker gets installed. But these are the commands for Linux, or I would say it is easiest to work with Linux. But if you are on Windows, if you are on Mac, then I would definitely discourage you to run this command. But suppose you are managing a server, you are managing AWS server, then also you can use this kind of command, because if you are managing AWS server, it may be Linux EC2. and you can use this command there. So let me choose this laser pointer. So this command is used in Linux. But if you are on Windows, then go to this link, and perhaps your best option is Docker Desktop. If you have Docker Desktop, then that is the best option. Otherwise, I have tried this on WSL Linux. It works. It works, but people recommend the Docker Desktop for Windows. But my knowledge is limited in Windows because I am a Linux developer. So you need to do some search on internet if you want to see how Docker works on Windows. But for Mac OS and Linux, I can give you more concrete information. For Linux, this command is good enough, and then you need to add the user into this group. Otherwise, every time you use Docker command, you need to use the sudo, which is not very efficient to work with. So if you give this command, then you don't need to do sudo every time you use Docker command. That is the idea. And when these two commands are done, when you see that Docker got installed, you can check with the Docker version. And this is what I said, if non-root user, this happens if you do not give this command. And subsequently, when Docker gets installed, when you do not need sudo, you can use just Docker info or Docker version to see how Docker got installed. That's the idea. This is how you install Docker and how it looks like. So let me show you how it looks like. When you install Docker, how it looks like. Uh, so this is my Docker running. And if you go to I have Docker desktop too. I have Docker desktop too. That's why if you go to the Docker desktop, you see the containers. You see the containers. I have one containers uh, that is stopped. It is, I have stopped it, but this is the container, and I can run it, I can delete it, I can do other operation, view files, I can see view details. If you see view details, then you can see what are the for example, inspect gives you a lot of information, and then logs give you a lot of information. So one thing that is important is whatever containers are running, they remain here in the Docker distro. That's why I'm asking for those who have Windows or Mac, then installing Docker desktop is easy for you because you can see all the Docker containers here. Okay. Now, when I talk about the container is something that is running, or I've stopped running, but this is not where the Docker starts. So let me go back to the slide. Let me show you how the Docker starts. You pull something called, for example, let me start. As I said, that this container can run Ubuntu, for example, and this container can be running Python as a process. So how I can run this container? To run this container, I first need to pull the image. Image is the OS files, operating system files. That is called image. Image is not the picture. That is not the image. Image is here in Docker language, we call the OS files. We need to download them from somewhere. Where? Where is that somewhere? You go here, you write Docker Hub. If you write Docker Hub, you go to a place like this, Docker Hub. It's not Docker, Docker Hub. And this Docker Hub hosts all the images. For example, if you want Ubuntu, Ubuntu 22. If you want Ubuntu 22, you can select, I need official image. I don't want any third-party image. For example, I may also create a Docker 22 image and upload on Docker Hub. I need to definitely sign up and sign in, and it is free. I mean, there are some cases, for example, for enterprise usage, you may need to pay perhaps, but otherwise for individual users like us, it is free. You can sign up and then sign in, and then you can keep your images there. But if you do not want any image from me, if you do not want any image from Sujoy Biswas, if you want Ubuntu image from only the official image, so click it, only the official image, and then trusted content officials. For example, it was not there. It was not there. When I clicked it, the search contained this, and then I can search and see it is written Docker official image. Docker official image is written here. Ubuntu. Ubuntu has this Docker official image. There may be other companies too who have this official image. But if I click here, I can start seeing the Ubuntu official image, and these are the various versions. Ubuntu 22, Ubuntu 24, Ubuntu 25, Ubuntu 26. I didn't know that 26 has been released. So it's interesting. So, and if you go to the tags, you can search. For example, Ubuntu 22. Oh, it's not showing. Let me see how the tags are organized. Uh, okay, it shows the newest. So here it shows Ubuntu Noble, Ubuntu tag. Okay, it starts showing from here. So these are the latest ones. Perhaps these are, if you click here, you can see more. If you click here, you can see more. These are the, so this is the AMD 64 version, Linux, which we don't need, perhaps. So this is the Ubuntu 24, perhaps these are for different reasons. We don't need that. So here it is, Ubuntu 24. And if you go down, then Ubuntu 22, right? And how you can pull this image on your system? This is the command, docker pull Ubuntu 20.04. So you can copy this command, and you can go here. You can go here and you can paste this command. For example, you can paste this command. And if you hit this, hit enter, then the Docker would start pulling this Ubuntu 22.04 on your system. For example, and if it is already there, it won't do. It is not on my system, because how I know it is not on my system? If you go to the Docker desktop, then if you click on images, oh no, I was wrong. I already have it. I already have 22.04. I also have 20.04. So if I have, then what happens if I pull it? Will it pull once again? Let us see. So it pulled the newer image because perhaps the version I pulled and the version it has the latest one is not matching, so that's why it pulled it. Now, if I see here, maybe the same version, perhaps some no, why it is not? Let me see why it is not showing. No, the it is the same version that got updated here. It is the same version. So that's why no new Ubuntu 22.04 has been downloaded. So this way you can download from Docker Hub. Docker Hub allows you to download these images from this repository, right? And it is the latest one. So my point is that you download the Docker images from this Docker Hub. So going back to the slide, that would be easy to follow now. So this is how you navigate Docker Hub. So these are the tag that you can check. You have seen those tags for 22. These are the tags, and if you want to pull this one, you can use the tag. You can use more sophisticated command to use this tag. Let us not go into that much of details. So Ubuntu image size is already shown here. So remember, I told you that the VirtualBox images may have size like 25 GB, 30 GB. And look at the image size of Ubuntu, 23 MB. Definitely, when if you run container from the image, then it expands, but it never goes into 10 or 20 GB. It may be few hundred MBs when it is running. But the point is that you download the image from the Docker Hub. The image exists as some bunch of files. That is the main point. Some bunch of files. It is not running on your computer. Images do not run on your computer. What I mean to say that images do not occupy any resource from your CPU. Images just stay on your computer as a file system. You can see, you can search a lot of images using this Docker Hub registry. I showed you, we don't have much time. I would encourage you to search and explore this official page. Okay, so that means if I need to search with this version. I didn't do that. Maybe 20.04. Yes, this is how I'm getting the 20.04 version. If I give 22.04, then I get 22.04 version. And these are the tags. And if you go here, if you go to the tag, if you click on this tag, then you see the last pushed by someone 20 days back. So it was the latest information. It was the latest information on this image, and it is the size information. And if you want to pull something like 14, shall I get 14 old? Yes, it is there, 14.04. You can also pull Ubuntu 14.04, all these versions. So anyway, you know now that where the Docker Hub, the Docker images reside. Okay. Once you have the Docker images, so this says just where to get the images from this particular block. Once you have the images, you need to run container. Container is the process that runs. It is a process, and it has a process ID. It is not a virtual machine. So you can run multiple containers from a single image. That is also possible. Multiple containers. You downloaded maybe Ubuntu 24.04 single image, and you run maybe 3 or 4 different containers from a single image. That is also possible. But image is single. You cannot download 2 images of same identity. It is not possible. That's why I pulled the Ubuntu 2.04, and when it got downloaded, it updated the old image. So I didn't see two Ubuntu 22.04. I have only one image. So image identity remains same. But you can create different containers from a single image. How to run a container? Let us see how to run a container. So Docker image pool, Ubuntu 20.04, I showed you how it gets pulled on my system. But if you want to run a container, step 1 is you pull the image and it lives on your system. For example, if you write docker image ls, these are the images you see I have downloaded. These are the images I have downloaded. Docker container ls. What are the containers running? No containers is running at now. At this point, no containers is running. So there is no container. Images are lying on my system, but there is no container. But if you do not like command line, it is easier for you to check the status from Docker desktop. You click on images. These are the images. This is same as this. This is same as this images. These are the Docker images. And what are the containers running? This container is stopped. It is not running. That's why it is saying that I can start it. So I do not want to start it. So there is no container running at this point. And this is the reason when I gave this command docker container ls, I didn't see any container running. Okay. But if you do not like command line, you can check the status from the Docker desktop. That's what I mean to say. Anyway, once you have this Docker image pool, you can run a container with Docker container run. So you can run a container with Docker container run. I can these are my Docker images, and I'm running a container. I'm trying to run a container. This I'm trying to run a container. So what is the command? Docker container run -it means interactive. Okay, I would be placed inside the container, and the name is my Ubuntu. This is my container name. So how do I run it from which image? So this is the image name. This is the image name, and this is the tag name. So there may be multiple image name. For example, Ubuntu may be present in multiple version like Ubuntu 20, Ubuntu 2024. So these are available in the tag name. So I need to write the complete name and tag name. So what happens if you do not give the container name? If you do not give the container name, for example, if you omit it, I'm not doing that. If you omit it, then the Docker provides some default name. The name is actually funny. The first name is the name of some celebrity, and the second name is Adjective. No, I missed the order. The first name is adjective and second name is some celebrity. So something like brilliant Newton or maybe sad Einstein, something like this, funny name. So that would become the name of your container. So once you run this container, you would be placed inside. So it is taking time. So you are now inside this container. You are not inside your host machine. So /c/ and this means you are inside the container. If you write pwd, you are inside the root. And if you do lsl, this is your inside the container. So your container is running right now. Look. So my Ubuntu. So your container is running. So 32 seconds ago, I have created this container. Okay. So this is your container, and you can do a whole lot of things inside the container. For example, I can create maybe is Python available here? Python 3 version? No, Python 3 is not available. And that is the beauty. It is so small that all the packages are removed from here. If you need, you can install Python on your own. Uh, is GCC installed here? GCC? No, GCC is also not installed. So you need to install. That's why they keep the container size so small. Okay. I'm exiting this container. I'm exiting this container. Once I exit this container, the container goes into the stopped mode. Okay. And then you can see all the containers that have been stopped or exited. For example, my Ubuntu. This container is exited. Now, if you want to remove this container, Docker container rm my Ubuntu. Uh, oh, I spelled it wrong. So now if I try to see if the container is there, no, it has been removed. It has been removed, so it doesn't appear here. The old container that I kept, which exited 8 months ago, it is showing that container ID as Ubuntu, but the my Ubuntu is removed. And so this container, when it runs, it runs as a standalone Ubuntu OS. This is the beauty. A standalone Ubuntu OS is running inside your machine. And it is powerful. Why powerful? Because you can create a small server, a Streamlit server inside this my Ubuntu. For example, I have this Python. Where is that? This Python Slim, this container, and I can start this container and I can start working on Python inside this container. I do not need to have Python 3.11 running on my system. So this is important. For virtual environment, you do Python level virtualization. With Docker, you do system level virtualization. This is important. The summary is that with virtual environment, you do Python level virtualization. You isolate your Python environment. But with Docker, you do system level virtualization. You isolate your operating system. Why it is needed? It is needed, as I told you, when you are required to work on complicated industrial projects. You need this kind of setup. So let us quickly go through this. Let us complete this. You run Docker, you are placed inside the Docker. Hash means you are the super user inside Docker. You can update it, you can play with it. Just pull the image, run the container, you update it, and you install some curl software, and the curl software can read web pages. You read the Google page, and then you exit, and you see Docker image list, Docker container list, and Docker LSA means you can look at the container which have exited in the past. Okay, this is not needed. For example, I showed an example how you can run a C++ file inside Docker container. You pull the Docker image, step 1. Step 2, you run the Docker container. Now you are inside the Docker container. And here, once you are inside the Docker container, you make a directory, you update, you install the build essential. Build essential has GCC installed. Once you have the build essential, then you write a small C++ file. Small C++ file. This is the small C++ file, and then you make the executable with g++ demo.cpp -o grit is the executable, and you execute the executable, it would run. So those of you who know how to run C++ file, they can quickly check this. This is very interesting. Inside your machine, a completely different operating system is running, and whatever you are doing inside that tiny operating system, that is no way interfering with your original operating system. The original operating system is called the host operating system. Host operating system. And the Docker system is totally isolated from the host operating system. So now remember, that client who came to me with this camera, and this camera has got an SDK that is very messy, that is very troublesome to work with, and if I install the SDK, that interferes with my files, and if I uninstall the SDK, then my files get deleted. Shall I take a risk of playing with this SDK with my host operating system? Definitely not. What shall I do? I would pull a Docker Ubuntu 20.04 Docker image. I would pull a Docker image, and then I would get into it, and then I would run inside it, and then I would start working on this, right? What is interesting is that when you run this command, you can add one flag D. D means detached. Detached means it would run in the background. It would run in the background, and when it would run in the background, you can actually Control yes, you can actually connect to your Docker container, attach to running container. You can actually attach to a running container. I mean, if I do that, it won't find any container. They are no running containers. But you can actually attach your Visual Studio Code to your running container, and that way you can do all this what I'm doing here inside your container. Your host system won't be affected. That is the beauty. Okay. So there, I'm reading the chat messages. So there, uh, perhaps if I go further, then these questions will be answered. Anyway, any other questions? So somebody was asking about various other characteristics of Docker file. Any question from others? If not, then I would. So why we are seeing all these things, I would briefly show you some demo which might make sense. No question. Okay. Code. So, okay, how Docker works. Docker pull Python 3.11 dash slim. We can find those names from the Docker Hub. This is another one. Search it out, what this Docker name is. And then you can run them. You run this way, and you can check which containers are running with this command, and you can remove the containers image this way. You can remove the containers image. But what is more important is, let us, if you run this command, you can you can visit your local host. You can visit your local host and you can see some HTML page is running. So I will share these files with you. You can check them, and you can test the container. For example, I asked you to know how the request library works. So when the container would be running on your port, on some port, which port it would be running? 8080. When it would be running 80 on port 8080 on your local host on your system. So when you go to this browser, you can see that. So you can interact with this container using this Python code. You can run this Python code, and so this is the this is the requirements. Only you need the request file. And just a moment. Sorry. Mm, when you run this, when you run this uh, Python file, it would interact with the container running in your browser at this location, and you can interact with this running container with requests.get. This way, perhaps one Streamlit server is running, perhaps one model is serving, you would be able to interact with that. Okay. Now, this is important. You do not want to download Docker file. You do not want to get into it and then manually type command, all these things. It is, if it is difficult for you, then what you can do is automate the full process. Automate means you write a Docker file. This is your Docker file. And what you write is from means it is the pulling command. Sorry, it is the pulling command. It is pulling this Python 3.11 dash sling. When it pulls that, it is something similar to the command that I gave, docker pull Python 3.11 hyphen slim. It is the same thing. Then work dir means inside the Docker, this directory is set as the working directory. It is the working directory. And when you copy requirements.txt, this is the requirements.txt. Sorry, this is the requirements.txt, because you want this Fast API, UVcorn, and Pydantic. All these softwares to be installed. All this software to be installed inside the Docker container. What you can do is, if you issue this command, then this requirements.txt would be copied into this working directory. Once you set /app as the working directory, dot means that working directory. So the system would copy requirements.txt from your host machine to the working directory /app inside the running container. And not only that, once it once it starts the container, once it copies the file, you can run pip install the command inside the Docker container. So these are the commands you want to run inside the Docker container. And copy app.py. App.py would be, this is the app.py that would be placed there, and expose means 8000 port is exposed to your host machine. What is the, how you can run it? You run it this way. Docker build, this is how you build the image. So corresponding to this Docker file, you would build a new image that is called model server v1. It is your own image, new image. If you search Docker image, this image would show up. And then if you run this image as a container, this is the name, sorry, this is the name of the container, this is the image, sorry, I messed up. So this is the name of the container, this is the image, and this image is this image. This is the image, Docker image got built, and this is the container that would be running. And the 8000 port of the container would be connected with the 8000 port on the host machine. So the container would share the 8000 port with the host machine, and it would allow you to open the localhost 8000 on your host machine. So the Docker container, see, the Docker container is running app.py inside this app, and all the necessary dependencies are installed from here because you have copied requirements.txt inside the app/app folder, and you have installed the pip installation there. And when you copy app.py, this app.py is the file that is running, because your command says this is the next command, cmd. Cmd means these are the commands, default command when container starts. So the container would start with this command. So app.py means this app folder would have this app.py. So when this app.py would be running, that app.py, let us see what this app.py, it is a fast API. It is the fast API that is exposing various endpoints, health, predict. Predict is some prediction function. Actually, it is just giving you some score. If the score, some fake machine learning model. If the score is greater than 5.0, return 1, otherwise 0. It is just pretending as a model that is predicting. So that is running inside this app.py, and this app.py is running inside this Docker container. And how you can run this Docker container? This is the shell command. You build the image first, you run the container, and then you listen to it on your host machine by visiting this URL. In fact, I have also included test_server.py. You can check if it is working by running this test underscore server dot py, by running this test underscore server dot py, you can do that. So you understand how Docker file actually um, automates this entire process. Docker file automates this entire process. Okay. Any question? No question. So somebody asked, what is the YAML file? Uh, it is a configuration file like this Docker file. Docker, I mean, we are running short of time, but still, just to answer the question, uh, so Docker file automates the creation of a single container. Single container, one container is running, and one container may be running some server, some model is running inside the single container. But what happens if you need more than one container? For example, this example, you are running one data pipeline and a model server. What is the data pipeline? So the Docker file shows data pipeline is you downloaded a Python container and you set the work directory, and then you are running pipeline.py. So pipeline.py is will be running when you issue the uh, when you when you would be uh, wait a minute. Yes. Uh, I know maybe you are getting overwhelmed, but I would be sharing all those files with you so that you can run them. And if you need some extra hours, I can spend extra hours by scheduling some time for walking you through all these things. But I guess the overall picture is clear. Now you need to play with these files. So you, what you need to do is that if you have this, if you have these two Docker files, one is data pipeline and one is this model server. When you have these two Docker files, how you can orchestrate or manage multiple Docker files? This is what this YML file does. Look at this, what it does. It runs the Docker file for data pipeline. Data pipeline is this container, and this container has its own Docker file. So it points at the folder structure. It doesn't point at the Docker file. Docker file is the default name. You cannot change the name of Docker file. If you change the name of Docker file, you need to use -f flag to force the system to find your new Docker file, and that is not advised. It is a convention. You need to name the Docker file as Docker file, like I wrote here. So this YML file, what it does is it manages multiple Docker file, data pipeline, model server, and how it works, how it runs, how it runs. You, the way you use it, Docker Compose. Docker Compose, this is the command you should use for running it, Docker Compose up. So I had this idea of showing you how Docker Compose can be run, but since I'm running short of time, maybe I give it as an assignment how to run the Docker Compose, or maybe I will write in uh, so once you do Docker build, then Docker Compose. Shall I guess instead of showing you the example, so in brief, it is that the YML file orchestrates multiple Docker container. That is the answer in brief. But instead of walking you through this, let me quickly walk you through the more important stuff, that is the ML ops part. That is, I guess, more important. I would take just 5 or 10 minutes. So this is the summary of Chip's book. So data collection, EDA, and data preparation, these are the part of the process. But when you are doing ML development, so what are the considerations that you may pay attention to? One is this. I mean, what are the criteria for selecting and building models and debugging techniques? So I mean, there are multiple ways you can do model improvement, and there are parallel algorithms. For example, distributed training, there is tracking and versioning. All these things are involved. And when we talk about the model development, remember there are multiple models used. I mean, not multiples. If I say multiple, that won't be the right idea. I would say uh, large number of models are deployed by a company. For maybe if we take the case of Uber, they are deploying model for customer request prediction, location prediction, maybe their own server parameter prediction, all these things. So at a time, many models run. AutoML is a technique where you can, while training, you can fine tune your hyperparameters. So AutoML can work in two ways. One is simple hyperparameter tuning for with the grid search. Another can be architecture search, which is the optimal architecture. You can use AutoML for searching the architectures. Evaluation is very important. Establishing baselines is important. And these are the recommendations that are available in the book, and this is the robustness and the refining, how you do the various tests and how you refine the performance calibrations and evaluation, you do that. And the deployment, how you deploy. As I said, the people think that only a single model is deployed. In reality, mature companies manage thousands of models. So not only multiple models, we are talking about a of models in order. So performance is not static. Performance changes because the data moves. Data moves means data changes, and this is the crux of the matter. When you deploy a model, you need to update the model with the new data coming. That's why the update is required. You need to update the model. Now, one question is how frequently you need to update the model. It depends. There are companies who are updating model at an interval of 10 minutes. So you can understand. So that is the scale these big companies are operating at. Okay, so I would conclude here because we are well past the time. Now, your job would be to um, explore Docker. I would be sharing the files, and at the same time, you would be encouraged. You are encouraged to go through this book by Chip. That is the machine learning system design. Okay, let us wrap up at this point. Let me see if there are any questions. So yeah, someone was asking me Uh, does this YML file combine pipelines with the other Docker container? Yes. So what YML file does is, if you have multiple Docker containers, it manages them. So in short, a single Docker file creates a single container. If you have multiple containers, each Docker container should have its own Docker file, because the Docker file would create that particular container. But all these Docker files will be managed or called by the YML file, that is the Docker Compose file. You need Docker Compose command to run this YML file. That is the Docker Compose YML file. Compose means it manages multiple Docker files. That's it. Okay. No, so here's the thing. We don't have class tomorrow. Maybe no class tomorrow. Last class is on, let me check. I know, but still, 8th June 2026 at the same time, at the usual time, at 7 p.m. So the last class is on 8 June 2026 at 7 p.m. Okay, but definitely if you need any help, if you need any extra class for doubt clearing related to the portions I covered, feel free to email me at this email ID. And also, for your information, some of you are asking me questions that require me to get deeper into this topic. For example, if you need discussion with loss function structuring and all this kind of technical details, please feel free to either email me or get into our Discord channel. So I would request Bidisha to share the Discord channel with you. If you I mean, this is not mandatory, this is no way related to your internship, irrespective of you join Discord channel or not. I mean, your internship would proceed I mean, as usual. But if you want to get help with more I would say with more personalized discussion, or if you need help delving deeper into the topics, so you come to the Discord channel where you can contact me personally. I mean, you can send me message with your query, and I definitely respond faster on Discord channel. So that's another option. So I would share the Discord channel with you. I would ask Bidisha to share the Discord channel. Okay, so we wrap up here. No. Oh, so there is one question I missed. Sorry. Is Docker very situational, or is it a regular stuff in professional setup working? It is widely used in industry, that I can confirm. And situational means I talked about just one situation. There can be hundreds other situations. What I didn't say is that Docker is widely used in deploying. For example, you deploy your model with Docker, you bundle it as a Docker container and keep it on your GitHub. And your server, which is actually deploying instances from several developers, it pulls your container and deploys it. So your server also deploys in the form of Docker. So Docker is not only used for this OS virtualization that I showed you. That was just one example to motivate your thinking, but the use of Docker spans many other areas. From deployment to CI/CD, all these pipelines. So, I mean, Google search, you'd get to know better. Okay, so another question. Would you please provide Discord and mail, please? Okay, let me give you the Discord ID right here. If I Yeah, the Discord ID is 6A. So let me write the Discord ID. Usually for your internship project, I use the Discord channel, but everyone is welcome. If you want to ask me personal questions, personal question means related to your internship. If you want to get in touch with me individually, then definitely Discord is a good channel. Good resource. Okay, 6A. Okay, I'm typing 6A KWT TU R3H. That is the channel. 6A KWT. No, I guess. No, I made a mistake. Sorry. A lot of windows are opening. That's creating the problem. Because I try to open the Discord. Six A K W T TU. Here you go. So the full URL is https discard.gg. If you click on this, then you would be taken to that particular channel. And those of you who do not have, they would be asked to register. Discard GG 6AKWT TU R3H. That's it. Okay. So again, there is no class. No class tomorrow. Last class is on 8th June 2026 at 7 p.m. That is for everyone to note. And here I conclude this session. Anybody, if you have any doubt, please get in touch with me on Discord. Also, you can email me and we will see you on 8 June, Monday at the same time. Thank you.
Thank you, Sujata.